After 300 years of telescopic examination, astronomers still knew very little about the planets of the solar system. Even the 70-meter Mount Palomar Reflector records only small, unsatisfactory images of the planets in limited range of wavelengths from a narrow locus of positions. In recent years, automated spacecraft enabled scientists to probe the planets from close up, observing radiation in all wavelengths, allowing photography at higher resolutions, and placing samplers and detectors near our neighbors in space. Space scientists have called the 1970s the great age of planetary exploration. Man has begun his odyssey toward the stars with automated Columbuses, which are revealing an almost completely new solar system. The inner four planets, called the terrestrial planets, have heavy rocky surfaces. Beyond Mars is the asteroid belt, a band of debris. And beyond the asteroids lie the much larger Jovian planets, made up of gases and low-density liquids. The sun itself is a great sphere of gas, emitting radiation and a solar wind of charged particles. To examine the space and planets between Earth and Sun, Mariner 10 was launched towards Venus and beyond to Mercury. But Mariner's first object of study was the comet Kohoutek, a temporary visitor to near-solar space. Data from the probe was coordinated with observations by the National Research Council of Canada. Kohoutek consists of a solid ice conglomerate core, surrounded by an envelope of gas and dust. Approaching the sun, the envelope increases and is swept outwards by the solar wind. After gathering data on Kohoutek, Mariner approached Venus from outside its orbit, so the first images transmitted show only a thin crescent. 3 hours past the closest approach, Mariner 10's TV cameras mosaic the planet using their ultraviolet filters. The ultraviolet photos reveal highly symmetrical spiral cloud patterns about Venus, presumably carrying energy from the equatorial regions to the poles. The equatorial regions show circulation features similar to those in Earth's atmosphere. Photos showed the subsolar point, the location directly opposite the sun, sets up unique patterns in the global circulation. Faint markings slanting from high latitudes to the equator suggest equatorial clouds rotate faster than the polar clouds. Assemblies of the photos show Venus's classic Hadley circulation, that of a slowly rotating planet heated from one side. Without a magnetic field to shield it, the solar wind has apparently stripped water molecules away from Venus's atmosphere. The flight path of Mariner 10 was planned to skim past Venus so the planet's gravity would bend the probe's trajectory to fly by Mercury. The closest planet to the sun displayed a battered, desolate, moon-like terrain, probably unchanged since the infancy of the solar system. While the surface is made up of light material, its center is dense. Like Earth, Mercury is differentiated into layers. Mariner also mapped Mercury's magnetic field. Such fields are probably produced by dynamo-like motion of dense liquid material in the planet's core. Of all the planets, only Earth, Mercury, and Jupiter are known to possess magnetic fields. Mariner's magnetometer and radiation detector also found Mercury has a bow shock wave caused by its magnetic field deflecting the supersonic solar wind blowing outward from the sun. The field is called the magnetosphere, and the boundary wave the magnetosheath. Careful planning of Mariner's orbit enabled the probe to circle the sun and approach the planet again. On Flyby 2, photos taken of the South Pole showed cratered plains and huge kilometer-high cliffs called scarps. Next, utilizing the pressure of sunlight as well as rocket power, a third photographic flyby was achieved. The pictures verified that instead of rifts, fissures, and other signs of tension, the outstanding surface features were the enormous scarps, suggesting the planet had shrunk over the eons. Studies of the ancient craters hint that they were made during the same accretion process in which all the planets were born. Our latest portraits of Mars, the fourth planet from the Sun, are the results of the Mariner 9 mission, revealing Mars as a geologically active world. The Martian atmosphere, carbon dioxide with traces of oxygen, was found to be only 1,000th as dense as Earth's. Infrared studies showed cloud cover to be crystals of water and carbon dioxide. Mariner's photograph showed areas where a visitor might think he was on our moon. But the data from orbit suggests that elsewhere the craters have been covered by lava flows and white clouds drift in the sky. A volcano gently slopes away in the distance, and the equatorial regions reach 20 degrees Celsius at noon. In the Great Rift, a colossal valley 6,000 kilometers long, endless dust storms scour the rocks. Near the poles, there are ancient terraces of layered dust and snow, deposited over thousands of years, each an episode in the history of a world. In order to probe the Jovian planets, the Pioneer missions were launched towards the asteroids and Jupiter. Pioneer 10 found the belt no barrier to future space navigation. Next, Pioneer approached the largest planet, Jupiter, orbited by 13 moons rotating in less than 5 hours. Its atmosphere a maelstrom of ammonia, methane, and helium. Each hour brings the giant planet 40,000 kilometers closer. Abruptly, Pioneer penetrates Jupiter's magnetosphere and starts to map that colossal magnetic field. Imaging instruments reveal huge coiling storm areas larger than the Earth, semi-permanent belts and zones similar to our cyclones and anticyclones, distorted by the planet's spin and Coriolis forces. Now Pioneer circles behind the mighty planet. The changes in its radio signals provide more data. Deflected by Jupiter's gravity, the probe plunges toward outer space. The data from Pioneer 10 suggests that Jupiter is an enormous cauldron of liquid hydrogen with a tiny molten rocky core. A hydrogen ocean, thousands of kilometers deep, has a temperature of 30,000 degrees Celsius at its center. Jupiter's cloud patterns are created by this internal energy, evenly distributed around the planet, unlike Earth's weather, which is energized by sunlight falling on the tropics during the day. Pioneer also charted Jupiter's magnetosphere, a loose outer region, and an inner torus shape, nodding up and down like a sombrero in the solar wind. Pioneer's images were computer-enhanced to produce magnificent vistas of the giant planet. After much deliberation, Pioneer 11 was directed to pass much closer to Jupiter, then continue on to Saturn. Closing in on its goal, Pioneer 11 scans Jupiter's moon, Callisto, for a possible future astronaut landing site. Because it escapes most of Jupiter's radiation, Callisto could be used as a base for studying the planet. Scientists speculate that each night Callisto's air snows out onto the barren terrain. Then at dawn, it flashes back from solid ice directly into gas in a few moments. The Pioneer's discoveries about Jupiter may hold clues to two of space science's greatest mysteries. Its composition could resemble the Genesis gas cloud, from which it is theorized the solar system was formed, a key to learning how the Earth was born. And its atmosphere, much like primitive Earth's, may give insights as to how life began, and perhaps even be home to Jovian life forms. Now, far beyond Jupiter, Pioneer 11 will reach Saturn in September 1979. Saturn, with its glittering rings and enormous moon Titan. Pioneer's flight path will carry it inside the rings, bands of dust and chunks of frozen gas. Then past Titan, where heat, methane, ammonia, and water may have reacted to form organic molecules. Finally, the automated explorers, first to reach the outer planets, will escape the solar system. Their missions are triumphs of engineering, important contributions to science, and fresh demonstrations of the potentials of the human spirit.